Learning target 15 is about still systems of conic sections. We're talking about systems of inequalities with conic sections. So again, I am simply bringing together all of this stuff that you already knew from all these other classes and then adding to conic sections we learned in here. That's all this stuff put together. So if you think about doing systems of inequalities, I taught most of you how to do them in Algebra 1, which is lines, right? You had two lines, you had the whole solid and dotted situation, you had to shade where the shading overlapped, that stuff, yada yada. Same idea here, okay? The first issue though, before I can even do any of those, they're gonna give you two inequalities. So the first thing you have to do is identify which conic section it is. Then you're gonna have to graph, which means you have to be able to graph all four types of conic sections. So I'm gonna try to do it the short way today, and that's fine. So I'm gonna go through all these different things and make sure you know the difference and make sure you know what you need to have in order to graph it, okay? That way you're bare minimum, you can do these things. First of all, telling the difference between the two. The easiest one to identify should be a parabola, because a parabola only has one squared term, right? Circles have x squared and y squared. Hyperbolas have x squared and y squared. Ellipses have x squared and y squared. Parabolas do not. So parabolas should be easy to identify, right? Okay. Circles, also pretty simple. Circles have an x squared and a y squared, and then something on the other side. There is no coefficient in front of that x or y squared, right? So it cannot be 5 parentheses x minus 6 squared. That doesn't work. It has to just be x or y. You can't have any coefficients in the front. Okay? So a circle you can only have x squared, y squared. You can't have anything in the front of that. With an ellipse, you could have a number in the front because you have to divide later to make it equal to 1, right? An ellipse, you have plus signs though, right? Hyperbolas, you have minus signs. So they're not, when you start looking at it, they're not that difficult to figure out. And I have made sure that the 3 examples I picked today have every single one of the conic sections in them, so we'll graph all 4 of them at some point. And that way we also need to work with them and like rearrange them, put them in standard form. We can do that too. I've picked good examples today for this purpose. Okay? All right. So what you need to have to graph them. All right, that's what I've made these lines over here for. Bare minimum. For a circle, the bare minimum things you need to be able to have to graph are the center and the radius. Right, the center is HK like it is in like every single section, right? Just don't forget that it's equal to r squared. So when you're trying to find the radius, you're going to take the square root of whatever's on the other side. Okay? Yeah? If you have the center and the radius, you can put the center on the graph, and then you can count out the radius in all 4 directions, and then make the best circle you can. Right? We go with circles. Okay. For parabolas, you need the vertex. Right? Now, just like in the parabola section, I'm not making you make these super specific. That's probably the bad of me as a math teacher. But you guys graphed a million quadratic equations when you were in Algebra 1 and Algebra 2. Okay? I'm just making sure you have the general idea, right, in different formats. So you need the vertex. You need to know if it's horizontal or vertical. How are you going to tell the orientation from a parabola? What's the difference? X squared or y squared. So it has x squared. Is it horizontal or vertical? Vertical. Right? That's every single quadratic equation you graphed in Algebra 2 had x squared in it, and they were all vertical. So it has y squared. It's horizontal. I know that seems a little backwards from the rest of them. I get that. But think about the ones you did in Algebra 2. Normal quadratic equations, right? All right. So you need the vertex, if you know it's horizontal or vertical, and you need to know what P is, and this is why. P tells you what direction it opens. If P is positive, then it either opens up or right, depending if it's horizontal or vertical. So if P is negative, then it opens down or left. You need to know the general shape to graph the parabola. So you need to know where the vertex is, what direction it's going, if it's vertical or horizontal, right? Which way is it opening? We okay with that? We'll work on some of those today. You're going to have to rewrite these equations and put them in the standard form, inequalities, put them in standard form if you're going to want to be able to do all this. Questions about parabolas? All right, for an ellipse, you need to know the center. That's not a surprise. You need to know the orientation, if it's horizontal or vertical. For an ellipse, how do you know if it's horizontal or vertical? No. Hold on to that thought. A squared. Yeah, sorry, I heard X squared. A squared. Whichever has the biggest denominator, right? If X squared has the biggest denominator, then it's horizontal. If Y squared has the bigger denominator, it's vertical. So A squared is always greater than B squared, right? So if you have X over A squared, that's horizontal. You have Y over A squared, that's vertical. The order doesn't matter because there's a plus sign in the middle, so you can write it however you want to, right? Now, in order to graph it, you need the center, you need the orientation, and you need to know A and B. That way you can draw out to where the vertices are going to be and make your ellipse. Okay? So then I told you to hold that thought. So if I have hyperbola, you need to know the center, and you know if it's horizontal or vertical. And how do you know if it's horizontal or vertical for a hyperbola? Which one comes first, right? Or which one is positive, right? We're assuming that the negative is going to be in the middle, right? So x squared is first. That's horizontal. Y squared is first. That's vertical. You also need to know A and B. A is always first for hyperbola. And then I'll show you some easy ways to graph a hyperbola today. The graphing part actually isn't going to be as bad as you probably think it is, but it's not. You don't. I'm not asking you to list all the pieces. I'm just asking you to graph it. Okay. All right. So I've given you some notes there before we start doing this. But again, it's all the same stuff. First thing you're going to do is decide what conic section you have. You don't know what conic section you have, you don't know what you're working with, that's going to be really tricky. So decide what conic section you have, right? You're going to graph the conic section. You know back in the day where you had less than and greater than as a dotted line and greater than or equal to and less than or equal to or solid line? That still applies. So maybe your ellipse has a dotted border instead of a solid border. That still is a thing. I know that's something you'll forget, but that's still a thing. Dotted is less than or greater than. Solid is less than or equal to or greater than or equal to. If it's equal to, it could be on the line. Okay. Then on the bonus question on the test, there was a question like this, right? It was about inequalities. And I said it was multiple choice for you to explain yourself, right? So you'll have to go through, some of you guys were using not sound logic. With a line, it's easy to determine what's greater than or less than. It's not so easy to determine what's greater than or less than for a hyperbola. Think about it. It's not so easy to decide what's greater than or less than for a parabola all the time. For circles, it's pretty simple. Greater than is outside, less than is inside, whatever. But the no-fail way to do this is to use a test point. The people that got it right on the bonus used test points. Right? They picked a point inside the two figures and decided if it was true or false, and they put it back into the inequality and knew where to shape. That's what I'm going to do all day today. Because no fail, you're going to be able to do it. Okay? And then the last thing is, it's going to come up in your homework, not so much in the examples today, which is why I'm mentioning it. What is the number one thing when you're doing inequalities that you have to remember? Just like normal inequalities, what do you have to remember about inequalities every time? It has something to do with the negative. What if it says you divide by a negative or multiply by a negative? You got to flip the symbol, right? So if you're rewriting these, and you have to divide by a negative, then you better flip the symbol. All right? So keep those things in mind. Again, this is a great section. It's putting together a bunch of stuff you learned before and putting it into conics. All right? So it's not an entirely new concept to you. The conics section is the only part that's really new. All right, I've got 3 examples today. I'm doing all 3 examples. Again, that way I can do every single conic section. All right, some of them are easier than others. Okay, let's go. All right, first example. X squared plus y squared is less than or equal to 100, and x squared plus y squared is greater than or equal to 25. What kind of conic sections are both of those? Circles. Because there are no numbers in front of the x squared or the y squared. Okay, so we know those are circles. The first circle, both circles have centers at what? 0, 0. The first circle has a radius of what? 10, and the second circle has a radius of what? Okay, great. I could graph these circles right now. Both of them are greater than or equal to or less than or equal to, so they're both solid. That's nice. I'm going to go ahead and graph the circle. So for the first one, you start at 0, 0. You go out to 10 in every direction. I'm going to cheat and use my circle tool. And you guys are going to do the best you can and not make them look like squares. Not a square. Same thing as the other one, you count out 5 though. Okay. So I got 2 circles. Agreed? If you agree, I have 2 circles. All right. Now to the shading part. Again, when you're doing a system of inequalities, you only shade where the shading overlaps. I'm going to go ahead and do test points, and you might not need them here, but I'm going to do them just so you know how they work, and make sure you keep that thought process going on the rest of these. So I'm going to use 0, 0 because it's in the middle of both the circles. Why not? So if I do the first one, and I use a test point of 0, 0, I substitute 0 in for x and y. So 0 squared plus 0 squared, is that less than or equal to 100? Well, yes. Yes, it is. That means for that circle, I would shade inside because 0, 0 is inside that circle. Okay, so I'm shading inside the big circle. I'm not shading the bigger outside circle.
Okay, yeah.
All right. Then I'm going to do a test point for this one. Again, you might not need them for this one. I get that. I'm just doing it. Make sure everyone's with me. 0 squared plus 0 squared, is that greater than or equal to 25? Well, no. No, it's not. So you would shade outside of the little circle, right? Because 0, 0 is on the inside. And if it's not true, that means you can't shade there. Right. So this one we would shade outside the little circle. And so in this case, where does that shading overlap? If you're shading inside the big one, outside the little one, it's the donut, right? So this is where you would shade. Right? Inside the big circle, outside the little circle. It's better because it's a donut. Whatever. Maybe a tire if you want it to be. What if you were supposed to shade inside the big circle and inside the little circle? Where would you shade? You would just shade inside the little circle. You can only shade where the shading overlaps, right? It does look like a glazed donut, doesn't it? Questions on the first one? Does that make sense? Yes? Circles are nice, aren't they? Okay. Can I erase all this?
Can there be one that's a circle and like one?
Oh, yeah. example on the back of your note sheet. What kind of conic sections are we dealing with? No. Parabolas. They're parabolas because there's only one squared term in both of them. Now, please be careful when you're doing this. Follow me on the first one, maybe. I need to put these in standard form so I know kind of some things that are happening. Okay? So I have x, the original equation says x plus y squared is less than or equal to 9. So if I'm putting it in standard form, the y squared stays where it is, and I move everything else to the other side. So that would mean I would subtract the x. Agreed? Now, in the standard form of a parabola, the x cannot be negative. It is not allowed. It has to be positive. So I'm going to have to factor a negative out, because the y has to be positive too. So I can't just multiply everything by negative, because then the y is negative, right? So I've got to factor out a negative. That changes to negative 9. That changes your vertex. That's very important. Everyone understand why we did that? The x can't be negative. Right? Standard form says there's a 4p in front of here. Right? So 4 times what is negative 1? Negative 4, right? So I know p is going to be a negative. So I know lots of things now. It says y squared. So if it says y squared, is this horizontal or vertical? Horizontal. I also know what the vertex is because it's in standard form. 9, 0. And since p is negative, I know that it opens left or right. I got a negative 1/4 because the 4 has to be positive. Yeah, the 4p, the 4 has to be positive. The x has to be positive. So since there was, the p had to be negative. P is negative, so it opens left. Right? It's horizontal. Everyone go with that. I'm going to go ahead and do the test point before I even graph it. Actually, let's graph it first so no one gets mad. Okay, so 9, 0 is my vertex. That's 10, 0. I can't count. My bad. 9, 0. It opens left, right? I'm not, again, asking you to do like the most perfect parabola. I'm not asking you if I can find points. You're just going to make a nice little parabola. It's my advice. I would extend it all the way over. Why am I asking you to extend it all the way over? Because you're going to shade stuff. Yes, Shannon? I'm guessing. That's what I'm saying. This could be a lot wider of a parabola, but I didn't ask you to do specific parabolas. I asked you to do the general idea. No, you don't find any other points. We're just graphing the parabola. I'm going to go ahead and do the test point so we know where we'd be shading for this one before I do the next one. Okay? Can I use 0, 0 as a test point? Yeah. So let's do that. You cannot use the vertex because it's on the parabola, so that's going to get confusing. But if it's a circle, you can use the center because it's inside. So I'm using 0, 0 because it's inside this parabola. It's definitely inside there. Now, you can put it into whichever version of this equation you want to. I'm going to go back to the beginning and put it in there. You can use whatever version of this equation we worked with all the way through. I don't care. So 0 plus 0 squared is less than or equal to 9. That is true. So that means I would be shading inside, like where the 0, 0 is. So I'm going to be shading, do not shade this because I have to do another parabola in a second. But I'm going to be doing this part right here, right? Yes? It's true, so you shade where the 0, 0 is. I'm going to erase that because we're going to not have that in a second. We're not going to have that whole thing shaded. So, yeah, we still have to do the other parabola. We're shading inside that parabola. Yes? Good? Now can I do the second one? So can I erase all the stuff with the first one? Except for the graph. It tells you if it opens left or right. If it's negative, opens left, positive, opens right. Okay, so can I erase stuff for the first equation? I'm going to leave the test point so I remind myself in a second where I'm shading. Okay, so second one. We have y plus x squared is less than or equal to 0. I need to rewrite this. So I have x squared. I'm going to subtract y. So I have negative y. I'm going to leave the 0 there for a second so everyone's with me. So what is wrong with that equation? Can't have negative y. So I'm going to factor a negative out again. So then I have to have 4p, right? So again, I'm going to have 4 times negative 1/4. Right? So this one has x squared. So that means it's what? Vertical. And then my center, or not center, my vertex is where? 0, 0. Why do I know that? Because it would be x minus 0 squared and then y minus 0. H and k. And p is negative, which means what? It opens down. Questions before I move on? Now, when I graph this one, I start at 0, 0. So 0, 0 might not be the best test point. So 0, 0 and it opens down and it's vertical, so it goes something like this, right? So we need to pick a different point. It doesn't really matter. I'm just going to use what I use because I know I'm going to use this one right here. So I'm going to use 0, negative 1. You can use whatever point you want to. Now, here's the thing, though. This is what we have to keep track of. If you pick a point inside the parabola, then if it's true, you shade inside the parabola, right? If it's false, you shade outside. If you pick a point outside the parabola, which is not wrong, then if it's true, you shade outside the parabola. If it's false, you shade inside. So keep track. If it's true, you shade where that point is. Okay? Yeah. All right. So this time I'm using a test point. I used 0, negative 1. Again, I'm going to go back to the original up here. So I have negative 1 plus 0 squared is less than or equal to 0. Well, negative 1 is less than or equal to 0. So again, I'm going to shade inside that parabola, where that point is. So the last one I was supposed to shade all of this, right? And this one I'm supposed to shade all of this. So the only actual part I'm supposed to shade is where it overlaps, right? Which is the little teeny part. We good with that? Yes? Questions? Going once? Going twice? That's okay. You can have plenty of questions in your homework. I'm okay with that. All right. Can I erase this or not? Okay. So, questions on this question. Can I erase this stuff into the next one? Yeah. All right. I am. The last one is not two of the same one. All right. The first equation. X squared plus 4y squared less than 16. What is this? It's an ellipse. It's not a circle because of the 4. You can't have a coefficient. So, this is going to be an ellipse. I'm getting there. And it's not. We'll talk about it in a second. So So it's an ellipse. I've got to write the equation for this. An ellipse has to be equal to 1 or less than or greater than or whatever. It has to have 1, right? Yep. So I need to divide by 16. So I have x squared over 16 plus y squared over 4 less than 1. Everything by 16. No. Yeah. So from this, is it horizontal or vertical? I'm working on the first one. This is horizontal because why? Yeah, 16 is bigger and it's under the x. What's the center? 0, 0. What is A? A is 4, B is 2. Okay. Everyone know where I got all that information from? Which part? Anybody? Question. Now, on this one, this is the first one we had to worry about this. You have to be careful. We've got a less than. So when we draw our ellipse, it is not a solid line. An ellipse is like the oval. Okay, so here's what I'm going to do to graph it. Graph the center. It's horizontal. That means it stretches out horizontally. That's the longer part. It's horizontally, right? So I count 4 in each direction, left and right, from the center. If it was vertical, I would count 4 up and down because it's supposed to be vertical. Longer part goes the way it's supposed to go, horizontal and vertical. B is 2, so then the opposite direction, I go that much. And then I make a dash. Oh, man. Draw an arrow and say dash. It's dash because it says less than, not less than or equal to. It kind of looks like a football. If we do a test point, we can use 0, 0 because it's inside of the ellipse. That's fine. I'm probably going to go back to the original up here because there's no fractions. It doesn't really matter, though. 0 squared plus 4 times 0 squared less than 16. Well, that's 0, all of that. So that is less than 16. So we would shade inside the ellipse, right? It's true. The statement is true. That means you shade wherever 0, 0 is. In this case, it's inside the ellipse. You can use whichever version you want to. The original, like if you had more numbers, the original doesn't have any fractions, so. No, this is true. 0 is less than 16. So you shade wherever that point is. So in this case, inside the ellipse. Can I erase the stuff for the ellipse? All right. The next one. Some of you guys keep yelling at me about it already. Oh my gosh. It's not a circle. It's a hyperbola. Here's the original equation. We have to get the x squared and the y squared on the same side if it's circle or ellipse or hyperbola, right? So I've got the y squared over there. The only way to do that is to subtract it. So then I have a negative. And if you have a negative, it's not a circle and it's not an ellipse. You cannot have a circle with ellipse with a negative sign in the middle. It doesn't work that way. Since it's a hyperbola, we have to have it equal to, or in this case not equal to, a 1. So we need to divide everything by 4. So you have x squared over 4 minus y squared over 4 equals 1. So from this, is it horizontal or vertical and why? Sorry, not equals, my bad. Less than or equal to 1. Where am I, what, where? This is from the last one. I left the test point stuff, so I know where to shade later. Is it horizontal or vertical? Horizontal because X is in the front and Y is negative. Whichever way you decide that, that's fine. What's the center? 0, 0. And what is A and B? Both are 2. Okay. Follow this with me. Because hyperbolas are not always the easiest thing to graph. Okay, so follow me here. Definitely pay attention to this. We graph the center, and then if it's horizontal, again, A would be horizontal, and you count B vertically. If it's vertical, the opposite. In this case, it's all the same. It's just 2. So 2, 2, 2, 2. Now, remember that box with the hyperbola? I'm going to draw on that box. I'm probably going to erase it later. You can do it. Remember there was asymptotes with the hyperbola? They go through the corners of that box. That's why it's nice to have the box. Here's your asymptotes. I'll erase those probably in a second anyway. That's fine. Yeah. Yeah. Okay. Now, we have to graph the actual hyperbola. It has to start at the vertices, which are, since that's horizontal, these 2 points I'm turning blue. If it was vertical, you'd use the ones at the top and the bottom of the box, but this one's horizontal. So, it follows the asymptotes, right? So it looks something like that. I do what I can. And then I am going to go back and erase all this stuff because it's going to confuse me in a second. Okay. Now I already know I'm supposed to shade inside the ellipse. We already talked about that. But now I got to do the shading for the hyperbola. Again, the same concept applies. So when I'm going to pick 0, 0 because I can. Okay? But if I pick 0, 0 and it's true, then I'm supposed to shade wherever the 0, 0 is. That's this big area here, right? If it was false, I would shade inside the branches. Okay? So keep that straight. Yes. So we're going to do the test point. I'm going to go back to the original equation because that's a lot nicer than the one I got. So 0 squared less than or equal to 0 squared plus 4 is 0 less than or equal to 4. Yes, so I need to shade where the 0, 0 is. So that's not inside the branches, all right? That would be in this middle, the hourglass part, right? Yeah, so it's where the 0, 0 is. So it's in the hourglass part. Now, it's got to also overlap with the ellipse, which is inside the ellipse. So it's only inside the ellipse. But it's only also the part that's doesn't have the branches. So it's just this part. So you have this like football without the edges. It's also not a square. Right? It goes out to where the branches are. So, okay. It looks like you took a bite out of both ends of the football, right? Pretend it's an oval cookie then. You took bites out of both the ends of the oval. Oval. Okay. So, this is the idea, right? You figure out what the conic section is. You graph it. You figure out where you need to shade. You do the same thing for the next one. You shade where it overlaps. Some of those are more complicated than others. I'm going to put the assignment up here. Remember, it's due Friday in the class. Now, the first 2 questions on the assignment, don't overthink them. One of the inequalities is a conic section. One of them is just a line. Okay? that should not be difficult. That should be pretty simple. But somebody's going to overthink it and try to ask me what kind of conic section it is. It's just a line. So tomorrow you have time to work. You have time to work Friday. I'm going to pass out the graph paper I have too.